This part is dedicated to the creation of the 2D maps and preparation for the 3D modeling.
In this part of the tutorial, we are going to use free software only to create a respectable 3D environment for our architectural project. In our example, I have chosen a beautiful village in Switzerland because it has a steep slope and an interesting environment. The first method, which is the free one, is based on extracting the elevation points directly from Google Earth Pro by drawing a path on the desired area. The points should be as dense as possible, because depending on your location you may be looking at a 10 meters resolution terrain like in the US or a 30 meters one like in Northern Europe, and just to be on the safe side, make sure that the distance between each point and the other is at least 10 meters, usually. I take a 3 by 3 kilometers square to draw my path, as my software of preference for 3D modeling will fail if I go any further in size, but if your software is stable with bigger objects you may go further as much as you like. You need to make sure that the close area to your project is detailed as much as possible. That's why you have to go closer and give it extra data extraction points.
Save the KML file and open it in TCX Converter and switch to the Track Modify tab to update the altitude of the data points. But this service is unavailable since the last trimester of 2019 up until the time of me typing these words, probably because the API key provided by Google for this service has expired. Fortunately, there are several ways around this issue. The easiest one so far is to upload your KML file on a GPX converting website like GPS Visualizer. Open your browser and go to the link provided in the description below. After uploading your file, check the GPX extension for your exporting output format and choose the ASTER or SRTM for the DEM elevation data. Just make sure that you are using the highest resolution. For instance, 30 meters is better than 90 meters, and 10 meters is better than 30 meters. After exporting the file with the GPX extension, download it and go back to TCX Converter and open the file there. Now you can see the altitude data unlike the previous method. Afterwards, save the file as CSV file and open it in an Excel sheet. You will have to make some modification on the columns. Firstly, delete all the data except for the altitude, longitude and latitude columns, and then rearrange the columns as follows. First longitude, second latitude, third altitude. This layout is called the input metric data points, and it is used in most if not all the software that generates the contours of a topographic surface. Now save the file and close it. Open QuickGrid and click on File Input Scattered Data Points, then click on Input Metric Data Points and open your CSV file. Now you should see a blue grid and some contours on it. You may just use this result, but the final terrain will have a mediocre quality. To have the best quality possible, we have to tweak some settings. Don't worry, I'm going to put the changed settings somewhere on the screen and in the description down below. The angle settings are used just for previewing the data, so you may skip this part. After doing this, you may export the file in a DXF format and open it in AutoCAD for some adjustments. First, you need to create a block from the contours, and then scale up the newly created block 100,000 times on the X and Y axes. The only purpose of this process is to have the right scale of your terrain. It is worth mentioning that now your geolocation is off by 100,000 times the original one. Afterward, you have to explode the block because we used it just to adjust the scale of the contours in my 3D modeling software of preference, which is 3ds Max will not recognize it as an object and it will be just an empty file. Finally, merge the layers into only one layer, preferably to the default 0 layer for a clean layers export, as 3ds Max reads each layer as a different object. The next chapter is a necessary step if you want the man-made constructions to be located exactly in their real location regarding the contour lines. That's why you will have to do this step now rather than later, so you can import both your contours and plans into your software of preference without worrying about any rescaling or shifting in position. The next step will be creating the vector plans of the roads, building and every natural biome of the area of interest, and to do so you will have to extract the data from OpenStreetMap. The first step is to go to the website provided in the descriptions and locate your project site, then click on the export button and choose the manually select area button to create a square centered by your project. After exporting you'll get an OSM file. Unfortunately, we are limited to 5 megabytes of conversion capacity as there is no free software to convert this type of file for free other than the listed website named MyGeoData, which has a limit on the exported data size. Now after accessing the website, click on the Browse Files to Convert button and upload your file. In my case I have exceeded the monthly limit. The easiest solution is to delete your browser cookies and other data to reset the website meter. It is worth mentioning that this data is not projected correctly, which will end up with a stretched plan. The most straightforward solution is to scale the x-axis as explained in the next section. The website will redirect you to another page which contains the conversion button. Just click on it and you will have your download link. Open AutoCAD and open the DXF files and put each one of them in a layer named after the type of the plans in it, which is the same name of the file. You don't have to open all the files, just use the ones that you need. Now create a block from every file. Then use the Design Center to join all of the created blocks in one file. All of the plans should be geographically located, which means they will overlap perfectly. You will have to explode all of the imported blocks and recreate one block from all of them, which will become handy in the next step. Now you have to put all of these files in the previously created contours and rescale everything 100,000 times on both axes, X and Y. The next step will be optional, in case you want to adjust the small defect in the drawings. You will find that the drawings are slightly stretched because of the wrong projection. Explanation of the problem: instead of using UTM projection MyGeodata, use geographic latitude longitude projection. You can fix this issue by following the next steps. First, enter to the block editor of the OSM plans and create a cross anywhere, then close it. Secondly, after closing the block editor, redraw the cross in the exact same place as the one you just created inside the block editor. Thirdly, enter the block editor again and locate your project location, and in the action parameters select the base point option and place it in the center of your project location to minimize the amount of distortion. Now close the block editor and relocate the block to match the reference cross. Adjust the block X scale in the parameters to 85,000 instead of 100,000, which will make the plans more reasonable. Please keep in mind that this ratio is just an approximate fixation of the problem to make your final result look the closest to the reality. Now delete both reference crosses. Before jumping to importing things to your 3D software, you have to explode all the blocks and to replace all hatches by closed polylines, because hatches are only readable by AutoCAD and cannot be properly imported to other software. You can do that by using the order hatch generate boundary in AutoCAD after entering the block editor and selecting all the hatches from each layer separately. Each time after applying the order, you have to make sure to change the layer into the corresponding one, as it will apply the default 0 layer each time you create the boundaries. After that, filter all the hatches and delete them. Now comes the tricky part. You need to change the location of the block with the known distance to separate it from the contour lines, and only then you can explode it. Because it has a uniform scaling, the polylines are going to explode too. To fix that, just use the Edit Polyline command and choose the multiple option by typing M in the command line to select multiple lines at once. Then you can use the Join command to create the closed polylines again. Now you have to return the OSM plans into their original place. Save the file with a DWG extension. Now you may proceed to the 3D modeling video to finish your terrain.